the second number. Yeah, when the person's picture is here, what does it mean?
The person was good.
But this no Nana WhatsApp.
Okay, so
All right, good evening. This evening we have a lecture on operating system terminologies. There are certain terminologies that we are supposed to understand. Terminology simply means terms. So as computer scientists, you will hear maybe a term throughput. What does it mean in the area of operating systems and all of that? So we'll go through some terminologies and then we'll move on to other aspects of the course as well. After the lecture, I'll download the attendance of the Zoom so that you will know whether you are actually here or not. That will also be recorded. And the attendance basically has the name that you are using now. So if you are using iPhone, if you are using a user or Zoom or something which cannot identify you as the person, then we cannot record your mark for attending. So make sure that you have an official name that can be seen when the attendance list comes to you, or your index number. So preferably, this is an official platform. So preferably, you should have your name and then your index number clearly there. And then that means that once my assistant checks and everything is fine, then you get your marks for being here. It is important you are here and then you are listening, and not that you are just online. Checking that from my side will be difficult. But whatever we do here, as I stated in class, is always an examinable question. So if you are here and you listen, it's better. Most of the time, when I finish a class, I send the recording to a platform that your class reps can also give to you so that you can revise. In fact, that is the advantage of an online lecture. An online lecture can be recorded, a face-to-face lecture, unless there's a video camera there to record. That one cannot be done. So we have advantages and disadvantages. An online lecture, a face-to-face lecture is more physical, and of course, it's more interactive and all of that. So once we are in a particular session, it has its advantages and disadvantages. All right, so let's look at some of these terminologies in OS. A user. So we know who a user is. In operating systems, there should always be a user. And a user is basically a customer in a computing environment who utilizes the computer to perform some work, meaning that the user is a person who is going to use the computer, a customer who is going to do one or two things with the computer, perform certain activities with the computer. And we always have to have the user as part of the components to be able to let the operating system actually work. Now, as I stated, if the computer has to be used, is a user that has to submit that particular work in the form of what we call a job. So what it means is a computer performs a job, a computer performs a task. How is the computer going to perform this particular job or task? Depends on the user. And you and I, we all understand that if there's no user, then the computer cannot function. The computer cannot do what it's supposed to do. And that is it. Now, what is a job? So relate the two. There's a job that has to be done, and then there's a user. That is it. And the user is the one who has to sort of submit a certain work to the computer. And that work is a job that the computer has to do. The job looks at a set of activities that or activities needed to be carried out by a particular user. So certain things have to be done. So for example, if the user wants to type a report, if the user wants to, let's say, work on SPSS, the user wants to use Excel, the user even wants to write a code, and the user wants to use a database for a particular activity. All of these are different activities which constitutes a job. But we have different users. So what you realize is you have a user who wants to do A, another user who wants to do B. And a user who wants to do either A or B will depend on what he wants to use that computer for. And that will determine the kind of job the computer has to do or what has to be carried out by that particular user as well. So a job normally is created by the user. It consists of a series of activities. So as I mentioned earlier, this is another example. Maybe if the user is compiling a COBOL program, COBOL stands for Common Business Oriented Language. It was one of the first high-level languages that came, or that was there before we have more object-oriented programming languages now. So the compilation using the COBOL program is a job, and normally we execute the loading model with a set of data. So a job is therefore made up of a number of job steps. A combination of job steps provides a job. The user is the one who has to give certain activities or give certain instructions for a job to be done. That job that is going to be done is going to be done by the computer, but the operating system has to make sure that that particular job will be done. And we have some job steps. So the job steps, remember, they combine to give a job. And the job steps is basically a unit of work specified by the user that must be done sequentially. So we have a unit of work specified by the user that must be done sequentially. It normally represents an activity in the job. A job gives rise to a number of job steps, and these activities constitute what we call, or what is called, a process. So reflecting on this, the unit of work that is specified by a user that must be done sequentially. So let's say you want to type a report using a word processor. Certain things have to be done. You have to take certain steps or certain processes have to be done one by one. You can't just start straight away. You have to start a program. That is one step. In fact, the initial step is even to boot the computer for the operating system to load. Once the operating system loads, you have to start the program. That is one step. Once you start the program, another step will be to locate the document that you want to work on, if it's an existing document, or to open a new one if it's a non-existing document. And then once that is done, then you'll be able to now carry out your work. Now, even the activities of knowing what to type and how to edit, how to format and all of that, all of these are job steps. But the main job that is being done by the user is to type a document. But in typing a document, the activities are broken down into different steps to be able to do that. And these activities normally constitute what we call a particular process as well in doing that. Now, the process looks at the sequence of actions that are carried out in order to perform a particular activity. And the process is created by an operating system that runs on the processor. That is it. Every activity that we use a computer for has to have a particular process, no matter how small we think an activity is. Whether it's clicking a button once, whether it's pressing one keypad once, whatever we do, any single activity needs a particular process for some of these things to be done. And if you don't know or go through the process well, or the computer doesn't do it properly, we don't see it executing. Nothing comes out of it. That is it. So it is possible also to split up a job into a number of processes as well, depending on what is it. And basically, there are two types of processes. We have the CPU process that we studied in class last week in terms of how the CPU works with the RAM. And then we have the input-output process too as well, where you will have an input and output device. Of course, that will give an instruction. And based on, if it's an input device, and based on that particular input, there will be a processing activity. We all know the stages of the data processing cycle and all of that. So in a nutshell, the job has to be done with a number of job steps. And these job steps have certain processes that they have to pass through. So if you don't go through a particular process, the job steps cannot be achieved. If the job steps are not achieved, we don't get a job done by the computer. And if there's no job done by the computer, then the user cannot also execute what he wants to actually do with the computer. That is how it is. So all of these are part of it. Now there's another term we call address space. And the address space is a collection of programs and data that will be accessed by a process as well. So if the process is going on, the operating system has created a process, and the process is linked to a particular job, and that particular job involves a job step for certain things to be done. Sometimes there's a collection of data involved in that particular situation, and that is what we call the address space. So the set of addresses that are available in a program, it will get to a point where we understand the differences between a program and then the process, and how many processes actually make up a particular program for a program to actually work well as well. So the address space normally is made up of the program space and the data space, whereby you have the memory address space that is also going to add to the input and output devices in terms of the address space. So putting the programs and data in the right perspectives, apportioning them so that each particular data or each particular program that will be accessed by a particular process will be available for that to be done. If you don't put them in particular addresses, or the OS doesn't do that, then it means that everything mixes up, because the OS deals with processes and there are programs and data involved in this. They should be categorized in a certain way so that this particular process involves this program and this data so that it works in that line. How Microsoft Word will be opened and started is different from how, let's say, a Java compiler will be opened and started and all of that. All of those involve different processes. And because of that, there should be address spaces for all of that. Otherwise, it doesn't really work. There's another term that is called batch processing. And the moment you hear batch, it means that you have multiple processes and one has to come after the other. That is it. So in a case where there's only one program in memory, using the total computing resources until completion before the next program. So there's a particular process that is going on. Until that is done, the OS doesn't allow another process to come in. So the processing is more or less done in batches, different categories that are done one by one in that particular order. We have multiprocessing. Multiprocessing means that there's a situation whereby the CPU, or you can have a situation where you have more than one CPU sharing the same memory and peripheral devices. So if you have heard of a dual processor, you have heard of dual core, maybe i7, dual core i5. The processor is not only one. The processor or the CPU is more than one. And because of that, when different jobs come in and processes have to be created by the OS, then it makes the computer faster in a way to be able to work on these jobs that will involve the job sets for the processes to go on and go on correctly as well. So multiprocessing means that processes can be executed at the same time. The CPU, or the CPU normally is more than one. Batch processing means that until process A is done, process B cannot come in and then continue. So obviously, from these definitions, we see that multiprocessing is, of course, faster when it comes to processing different aspects of instructions that a user will give to a computer or data that will come from a user. So the multiprocessing permits execution of two or more sets of instructions simultaneously and all of that. That is why we should understand that even if you are typing with your phone, you are typing with your keyboard, and you are pressing the keypads very, very fast, all of that is part of multiprocessing. It allows you to type and everything comes quickly. You see everything coming on screen and all of that. You can do different things too in addition to that. They are all part of multiprocessing activities as well. And then we also have another term called multi-program. Of course, when we hear the word multi, it means that it's more than one. And multi-programming means that you have more than, or when the OS has a situation where there's more than one program in memory sharing the resources of a computer. So you have a random access memory that has a PowerPoint slide on, just like the laptop that I'm using. At the same time, I have my browser on with different tabs on. I have Microsoft Word document that is also open as well. There's an Excel file also open. Many, many programs are open. It's called multi-programming. That means that the OS is able to look at all of these programs, the processes that are involved in all of these programs, in terms of the jobs that I will do as a user, is going to take care of all of that. The job steps that are involved and all of that. It looks at all of it and is able to take care of it without any problem. So the programs normally take turns in doing the actual processing that is required, because you cannot use more than one program at a go. Whatever you do with a particular personal computer or a computer in itself, once you're a user, there will be one particular thing that you are doing at a time. That is it. So the CPU can be idle at a particular time. You call it CPU idle time when it doesn't have anything to process. But the moment you start giving certain instructions using the devices to do one or two things, then the OS has to create that particular process for those activities to be done successfully without any problem as well. So one can increase, or we can increase the number of programs until the CPU is never idle. Most of the time, the CPU is working. Once the processes and jobs are coming in, it will continue to work without any problem at all. All right, so there is another term called time sharing. And time sharing refers to the ways of using a computer system to share the resources of the computer among several users at a time, especially in situations where you have one server which is being used by multiple clients. An obvious example is a wireless network that has a particular access point. Everybody is trying to access that particular network by connecting to it. And a lot of people are accessing, let's say, ATU network or something, especially in networking. So several users at a time, and this gives a better turnaround time than multi-programming environment. The multi-programming environment is maybe one person sitting beside a particular computer, and then the OS allows him to open many programs, and they can use different programs at a go and can open them and move from one program to the other. But you have a case where you have several users that are also having a time to share computer. So each user is given a particular time unit, after which the computer resources are assigned to the next user. So the multi-programming is normally for one, where you have multiple programs open for one person. You have a situation where the time sharing tool is for several users. So it means several users that are maybe connected to one main computer, but they can do different things at a go. That is it. There's an important term in operating systems that we call interrupts. In fact, interrupt and interrupt handling is one of the topics that we have to go through. And the interrupt is normally a mechanism by which the processor is found to take note of an independent or an exceptional event. So we have a case where there can be an occurrence of an error, hardware malfunction, or anything of that sort, and all of that. So we have these situations where you can see that you are using the computer and you are performing a particular job. And in performing the particular job, you are using hardware devices, maybe input devices. So let's say you are typing on a keyboard. That process is going on. All of a sudden, you stop. Once you stop that particular process, you then take a pen drive, and then you are going to insert the pen drive into the USB port. The OS should understand that one process has been interrupted, one process has stopped, because the user needs to, after maybe clicking the mouse and maybe typing on the keyboard or doing something, he stopped that. The OS has to be able to see that activity and stop that particular process, initiate the next one when the USB is inserted into the USB port for that process to now continue. And if you eject the pen drive or you leave it in, or you copy whatever file and you put it onto the drive and you stop, that process too terminates for another one to also go on. That is what interrupt actually means. And if the OS does not look at current states to be able to know that the user is doing this, he stopped, he wants to do that, he stopped that one, he wants to do this, and he doesn't regulate that particular situation well, no user can use a computer effectively if the OS does not understand how to go about some of those things and do it well. That is it. So we have a supervisor state. In fact, there are different process states. We've not gotten there yet. We'll look at the different process states that are there. But we have the supervisor state. And the supervisor state is the state of the CPU in which a program is running, and it has to access the facilities of the entire computer system. That is, it has to access almost everywhere. You see, we have situations where accessing of access that is done by the CPU has to go at different places, different places. So it depends on which particular program and which devices are involved in what you do. There are some programs that maybe you use only the mouse. What you are doing is only menu driven, it's only about mouse. There are some that you combine maybe a mouse, you combine a keyboard, you combine all of that. So many things are done. Someone can use Microsoft Word, and then the person will only type, and then that is it. Now, another person might type, print what he's typed. After printing, the hard copy comes. Maybe he will even scan in addition to that. So the CPU at that particular time is in a supervisory role, meaning it's performing a whole lot of functions because that particular user is doing a lot of things. And that is called a supervisor state, when the CPU finds itself accessing so many facilities of the entire computer system because the user is doing certain things that are demanding that. That is, all of these are user dependent. We have a situation where there could be a problem state, and this particular state looks at the CPU in which there's only, or the program permits only the use of non-privileged instructions. Sometimes you need certain instructions which don't really have to come in at a certain point, or these instructions which are coming in are not really relevant to what has to actually be done. There are certain instructions which go in by a user that may not be so necessary, that may be ignored. And these instructions come in where, for example, you go into an area that, let's say, right click doesn't work, left click doesn't work, but you are doing it anyway. Those are problem states. The CPU will not even do anything with that. It won't permit those sort of things to happen. But when it is in a certain situation and you get to a state where those things are important, then it may allow all the programs to be able to function and come in and all of that. So there are certain situations where the OS has to be measured in terms of efficiency. Every OS has a response time. Every OS has availability. Every operating system or OS has throughput. We are going to look at the next slide to see what it means when you mention response time of an OS, availability of an OS, and then throughput also of an OS as well. So response time. Let's look at response time. Response time is the measure of the time between a request for some of, or a request for some computer system's attention and the time an actual response is made to that request. That is it. That is what response time is. And response time is also used in software reliability a lot to see how softwares respond and all of that. So if you engage an operating system, you start a program. The question is, does it start or not? Do you see the program starting or not? Once the program executes and is starting and is running, the next thing is when you are using the program itself, maybe you've opened Microsoft Word, for example, and then the OS has responded by starting that program for you. It means that the response time is very, very quick. It doesn't take long for it to start for you. And then once you are using it too, you don't have any issues with it. Everything is working well. It means that the response time is good. We have availability. So this is a measure or the measure of system accessibility. To what extent is that particular system accessible? To what extent can we get that? And then the ratio of the time a hardware device is known to be operating correctly to the total time of the schedule of operation. So, or schedule operation. So, we have hardware devices, and these hardware devices, the extent to which they operate correctly too is one thing. If a hardware device is malfunctioning, it won't allow the operating system to also function well. Because if the hardware in itself is not working well, there's no way the operating system itself will work. So we have to have the hardware actually available and actually there functioning properly to be able to collaborate with the OS and make sure that when a user is performing a particular job, then that one will work. So normally we say that the OS is available, let's say 99.9% or 95%. What it simply means is one, the hardware associated with that computer is working well. Everything about it is fine. And the hardware corresponds to the operating system when a user gives any instruction for the computer to process. And based on that, that one too works as well. Throughput is a term that is used in computing a lot. And what is throughput? It's a measure in terms of operating systems. It's a measure of the amount of work done on the computer system per unit time. Of course, if a computer will have a strong throughput, it means that it has higher specifications of CPU and then RAM. Remember, the CPU and then the RAM are the powerhouse of every computer. No matter how small, no matter how big, when it comes to processing, these are the processing devices or processing hardware. So if a computer processes jobs at 50 jobs per second, another one processes at 100 jobs per second, then the one with 100 jobs per second has a higher throughput. And how would you have one with 100 jobs per second? That one has a faster CPU. That one has a RAM with a higher capacity. And because of that, the relationship between these processing devices allow it to be fast. That is basically it. That is it. So standard jobs are normally called benchmarks, and they are used so that the different machines can also be compared to as well, to know that this one has a higher specification than another. Now, we have to note that this does not merely reflect CPU speed, but rather the system as a whole. But basically, that is it. Because if you have a CPU which is fast, and maybe the RAM is not commensurate with that CPU in terms of compatibility, it may not be very, very fast. So we need all of those to come together to make sure that everything will be fast, to be able to achieve the throughput. So I think this looks like a repetition. All right. So that is for the terminologies. We'll look at components too as well. And whatever we are learning here, there are things that we'll use in subsequent lessons. And in these subsequent lessons, some of these terms may come up. That is why it's important we try our best not to forget them. We'll revise and make sure. All right. Now, the components of OS, we'll start with process management. I mentioned this in class when we met last week, that when you look at an operating system, the main things or the main activities that OSs do is process management, memory management, we have file management and others, but process management is the first one that comes. And if you look at how we started today, I've mentioned job steps, I've mentioned processes as well. So process management is core of every operating system. And the operating system manages many kinds of activities. What does it manage? It manages user programs, it manages system programs, like servers, file servers, printer spooler, and all of that. Every hardware activity, every software activity is managed by the operating system. So these hardware and software activities too, they are all processes. When you press Control or Delete on your keyboard as if you want to start the computer, and you click on processes, you see so many things going on there. That is how it is. So the process management is what OSs do. And each of these activities is encapsulated in a process. So a process includes the complete execution context. It could be about code, it could be about data, it could be about resources, it could be about registers, and all of that. It could be about all of this and all of that. The moment one activity, the moment instructions go to a computer, a process has to be created for it. And it's always important to know that a process is not a program. A process is only one instance of a program in execution. What does this mean? You have a program in execution. Microsoft Word, Microsoft PowerPoint, Microsoft Excel. Maybe, let's say, even a computer game. Let's say Microsoft Visio for drawing. They are all programs. But when you are using Microsoft Visio to draw, you would have to pick the shapes one by one, depending on what you are drawing. It could be a schematic diagram. It could be a conceptual framework or something. But you have to pick each of them one by one. And those activities that we do in a particular program, that is what processes are. So normally we say that multiple processes occur in a particular program. That is how normally we say it for it to go on as well. So there are many processes that run in the same program. I just gave an example of Microsoft Visio. And the 5 major activities of operating system in regard to process management are the following. What are the 5 major activities? The first one is every operating system creates and deletes, or creation and deletion of user and system processes. Every operating system has to create a user or a system process. Every operating system, once the process is done, it's not relevant anymore. That process has to be deleted by the operating system all the time. That is what computers do through the OSs. The operating system either suspends or resumes a process. What's the meaning of a suspension of a process? Something is going on and then there's an interrupt. It has to suspend it. So typing on the keyboard there are processes going on within a particular program. The user stops and then goes to use another device. So another process will be created for the second activity. Now, once that is done and it's over, it terminates the second one, initiates or resumes the first one. That is what OSs do. And we have a mechanism for process synchronization. What is process synchronization? Process 1 was going on, and it had to stop for process 2 to continue. And process 2 may stop and process 1 will come again. All of that is about synchronization, to be able to look at the two and synchronize them. And then we have a mechanism for process communication. During the synchronization, there should be a way in which these processes also communicate. and how the communication also goes on in each of them as well. And then we have a mechanism for deadlock handling. And handling of deadlock means that you shouldn't let processes conflict. And it gets to a point where the operating system should know which process has to be done in comparison to another, so that there will not be a problem of the processes locking horns and clashing. Once that happens, it means there's a deadlock. The computer doesn't actually know which process to actually execute. But once there's effective communication and synchronization amongst processes, and there's IPC, inter-process communication, and it's going on effectively, there's not going to be any problem of deadlock situations at all. All right. Now we move from processes to what we call memory management. And memory management is also part of the main components of an operating system. Remember, the memory is made up of primary and secondary. The primary memory is about the RAM and the ROM. The secondary memory is our secondary storage devices, our hard disk drives, our pen drives. Any device that has permanent storage is secondary. Any device that has temporal storage, especially the RAM, is the primary memory as well. So the primary memory or main memory is a large array of words or bytes. Each word or byte has its own address. And then the main memory provides storage that can be accessed directly by the CPU. So if there's no RAM, then whatever is being processed, that is stored, or the storage activities of a CPU cannot be done. That is why the CPU always works with the RAM when it comes to processing of instructions. They're all processing activities. They work together. Everything, because whatever the CPU processes has to be stored somewhere. This PowerPoint that is being used now, that we are looking at currently, whatever processing that is going on, when I press right arrow key on the keyboard, you see that the next item comes. But how are we going to see the next item if there's no RAM to store that particular process after the activity has been done? That is it. So the RAM takes care of that. So normally when we say that a program is to be executed, it has to be in the main memory. The program has been executed, meaning that you've seen results of an instruction. You have to see it in the main memory. Otherwise, it doesn't become visible enough as well. That is it. So the major activities of an OS in regards to memory management are the following. Let's look at them. The first one is every main memory, or let's say in terms of memory management, every OS has to keep track of which part of the memory are currently being used and by whom. Which part of the memory. The memory has different sectors. For example, you have a hard disk. Your hard disk in your smartphone, your hard disk in your laptop. It has all your files. It has the operating system itself. It has maybe your Microsoft Office. It has your applications. It has so many things. These items, they have to be stored and stored properly. And then they have to be able to go into particular locations. And they have to be tracked. Because how is the hard disk going to know that, or how is the operating system going to open a particular application from a hard disk? That aspect of the memory concerning the hard disk has to be managed. And it's the OS that has to do that. To be able to know that this has to leave the hard disk. This has to be copied to the hard disk. This has to be copied to the pen drive. This file has to be renamed. This folder has to be renamed. This file has to be deleted. This folder has to be deleted. All of those things that we do is all part of memory management and all of that. So deciding which processes are loaded into memory when memory space becomes available. So you have some space available on a hard disk, some space available on a pen drive, a space available on a RAM. Where or who is going to determine, or which device or which resource is going to determine that this particular file should go into this area of the hard disk. And this particular item that has been processed should be in this part of the RAM. It's only the OS that can do that through memory management. So without the OS, the memory cannot be managed properly. Where certain items have to go, when certain items are deleted, where it actually goes, and others and all of that. All of those things cannot be done. So allocating and deallocating memory space as needed. So the OS, in terms of memory management, does all of this to make sure that if there's a memory space that is required, it will provide by allocating. If there's a memory space that has to be deleted or something, then it will delete it and make sure that that space can be used for future. That is it. So to verify that this hard disk is 100 gigabytes, the hard disk, the use space is 40 gigabytes, and then the free space is 60 gigabytes. All of those things that we see in the Windows operating system. Without the OS managing the memory devices and all of that, we can't get all of those things happening. So that is it for the OS. We have file management too. So one is about managing processes. One is also about file. That is what we are going to discuss. Another is also about memory as well. Now, a file system is normally organized into directories to ease their use. The directories is a technical term in computing, which is the same as folders. So in computing, normally we mention directories. But to a user who is not, computing oriented, that person will mention the folder. So these directories may contain files and other directories too as well. There are 5 major activities of an operating system regarding file management. So remember, the operating system manages the memory of a computer. The operating system manages the processes of a computer. And then the operating system also manages the files, folders, or let's say directories of a computer. You cannot create a folder, delete a folder, rename a folder, copy or paste a folder, all of those activities that we do without the influence of an operating system. It can't happen. So the creation and deletion of files, that is one. The creation and deletion of directories or folders, that is also another. We have the support of primitive and processes for manipulating files and directories in terms of deleting, maybe renaming a file, copying and pasting, and all of those type of things moving. And then mapping of files onto secondary storage devices and all of that. Which file goes there and all of that. So the operating system will manage the files in addition to seeing that this particular file has to go here, all of that. Or when the user directs that a file should be saved in documents, a file should be saved in downloads, and then he gives that particular instruction, the operating system has to make sure that within the downloads folder on the hard disk, the file that the user wants to go there is ideally going to go there. And then it's going to work in that particular regard. That is it. Issues about backup of files in unstable storage media and all of that, the OS takes care of that as well. Now, secondary storage management is just a branch of memory management. And we're going to look at what the OS does when it comes to secondary storage. Issues about levels of storage are different. We have the primary storage, we have the secondary storage. We also have the cache storage too as well. So when we look at instructions and data, they will be placed in the primary memory or the cache. The primary memory or the cache memory, which is very associated with the RAM in terms of some extra space, normally is used when a program is running. And as we discussed in class, as for the RAM, it's always temporal. Whatever you are using a computer for at the particular time T is in the RAM or the primary storage most of the time. So the issue about the main memory is the fact that it's too small. It cannot accommodate all our data. It cannot accommodate all our programs. We are talking about 4 gigabytes of space, or maybe 6 or 8 gigabytes of space. That is the maximum, But when you talk about hard disk drive, we know that it's high. Some are even in terabytes and all of that. Those who have laptops and other machines, you know. So when there's loss of power, we know that everything goes, we don't see it again. So the backup, or when we want something to be permanently stored, of course, then we need a secondary storage for that. Otherwise, we don't get all of that happening. All right. So the secondary storage looks at tapes, looks at our disks, any other forms of media. We know all of them. You mentioned hard disk, you mentioned the USB pen drives and all of that. Any device, our CDs, our DVDs, once it stores permanently, that is it. So those are some of the differences. And each of these, or each particular location in storage has an address. We've already discussed address, and normally that is what is called address space. So the address space is also linked to the secondary storage devices too as well, in terms of certain data that have to go in there for it to work and work effectively. So we have three major activities also when it comes to secondary storage management. So every OS has to manage the free space available on a secondary storage device. I mentioned that when you want to see the properties of your hard disk, just right-click on it in Windows, you see the free space, and then you see the use space and all of that. The OS has to manage that. If you want to defragment your hard disk, you want to clean it up, you want to do certain things, it's the operating system that takes care of that. We have allocation of the storage space. So when new files have to be written, when new files are created, when new files have to be stored, that is the technical term for stored, the written is technical term. Then it means that the allocation of these new files, where it will go on that particular device, is determined by the operating system to make sure that it goes into it. If you want to create a particular folder or a directory on a hard disk, a folder on a pen drive, or vice versa, however, has to be done depending on what the user is doing. Then it means that the OS has to give that access. Then we have scheduling the requests for primary memory access. That is it. So let me explain what this means. The primary memory always makes requests from the secondary memory. The request simply means that you have a file on your pen drive. You have, let's say, a PDF file on your pen drive. You want to open that file on your laptop. So you insert the pen drive into the USB port. Then you instruct Windows to open your pen drive. All of these are processes as I've mentioned earlier. And once the pen drive opens, then the PDF file will be on the pen drive. The moment you double click on that PDF file and it opens, it means that the RAM is working with the CPU to make sure that you can see that PDF file opens. But once it opens and you see content of what that file actually is, it means that the RAM has made that particular request from the USB, because the USB has where the file actually is. So the RAM cannot get it automatically, but to work with the CPU and make that particular request. And the request is simply the user double-clicking on the file, giving it an instruction. That is the instruction that the user will give. The job that the computer has to do at that particular point is to open the file. That is it. Once it opens the file, and then you are now going to do certain things in that particular PDF, then that becomes another job. And maybe there are certain job sets that will come together for you to be able to do that particular job. So the scheduling of these requests that have to be done by secondary, by the RAM, is what the OS also has to manage and all of that. So we always have to remember that it is whatever is in the secondary storage that has to be fed into the RAM, which is the primary memory in this case, for us to be able to use the computers. Otherwise, it doesn't come there automatically. No, it doesn't come there automatically. So we have the main memory, which normally looks at the storage media that the CPU can access directly. The storage media here is the RAM. basically our random access memory. The secondary storage is the extension of the main memory that provides large non-volatile storage capacity. Large non-volatile storage capacity. So it is always higher than our primary memories too as well. And then we also have the magnetic disk, rigid metal or glass platters covered with magnetic recording materials. The disk surface is normally divided into tracks, which are subdivided into sectors. When you look at the hard disk internally, if you look into different books, hardware books, you see it. The hard disk has a particular surface. This particular surface is metallic, and it has different sectors within different file sectors. So the OS knows what is on the hard disk and which sectors are filled, which sectors are empty. And it works in that way to be able to know that this particular item has to go into this sector or that sector to be able to store certain things properly. And we have a disk controller that determines the logical interaction between the device and also the computer. So the disk controller is more or less like the device driver that we mentioned, or the device controller that is going to allow the hard disk to be able to work, or any other storage device, secondary storage device, to be able to work as well. So the storage systems, they are organized in terms of a hierarchy. We have speed, we have costs that are all associated with storage systems or devices. We have volatility too as well. So in terms of speed, or hard disks, they spin. So that form of speed. And RAMs too, they work in terms of that connectivity on the motherboard too as well. In terms of cost, secondary storage devices are basically more expensive. In terms of volatility, the primary memory focusing on the RAM is volatile. Secondary storage devices are non-volatile. They are always permanent. And then the primary memory is temporary in terms of storage too as well. So caching means that we are copying information into a faster storage system. And the main memory can normally be viewed as a last cache for secondary storage. We'll discuss caching and issues about swapping, paging, and all of that when we go into the lecture of memory management to be able to understand all of that as well. Okay, so there's a diagram here which is looking at the connectivity of the main memory to the electronic disk, which is more or less like a hard disk. Magnetic disks too are there, older forms. We have the optical disk linked to TVs, the magnetic tapes were also there. We have floppy disk drives and all of that in the past. They were all secondary, you see. So all here, all of these, electronic disk, magnetic disk, optical disk, magnetic tapes, they are all secondary. Everything here is secondary. What we have at the top here, at this particular side, is related to the main memory, which of course works with the registers, and then the cache memory in case certain extra memory is needed or copying, or certain aspects of the main memory has to be copied and utilized in terms of extra space, then those ones too can be done as well. So protection of a computer system means that you can have multiple users, and these users are going to undergo multiple processes, especially in an environment where you have, maybe it could be a computer lab, it could be at a workplace where there are so many computers and all of that. And there should be a way, or a mechanism to control the access of programs, the access of processes or users to the resources defined by a computer system. If you go into certain organizations, you cannot even use a pen drive on a laptop. They block the USB. They block the aspect of putting even an earpiece in a port. They block so many things because maybe they employed you to do ABC. So they limit you to be able to do that. And there are ways in which the OS can be manipulated to do that. So many things can be done. You can block sound. And before a person can do that, unless he's the administrator, to be able to perform some of these functions and stop it and all of that. So we call it protection. to make sure certain things will not be done. All of these settings are there. It's called the control panel, and all of those things can be done. We have the command interpreter system. That one is an older form of an operating system. We had an operating system called the disk operating system, the DOS, and DOS use certain commands. You had to be able to understand before Windows came. If you want to make a directory, you want to delete a directory, you want to rename a file, and all of that. Certain things could have been done based on certain command prompts to be able to do that. So the user will normally give commands which are executed by the operating system, and these commands have to be understood well before you be able to. But honestly, these things, they are past. You don't need to know those commands anymore. It's above that. Now the operating system that is there, once you know what to do, how to do certain things, and you know how to go to certain places with your mouse to be able to do it successfully without any problem as well. All right, so finally, we'll look at the operating system types. We have different types of OSs. Some are industrial, some are personal, used in different situations. We have, within a broad family of operating systems, there are 4 different types. And based on the type of computer and the control and certain things which have to be done, you may need a real-time operating system. You may need a single user operating system. You may need a multi-user operating system and all of that. So let's look at these 4 types of OSs. The first one is real-time, RTOS, real-time operating system. We have single user, single task operating system. There is single user, multitasking operating system. And then we have multi-user, multitasking operating system as well. So these are the 4. These are the 4. Let's look at the 4 and see. The real-time operating system, RTOS. So real-time operating systems are used to control machinery, scientific instruments, and industrial systems. Again, they are used to control what? Machinery, scientific instruments, and then industrial systems. So we have some examples. We have the free RTOS, we have VxWorks, we have QNX. They are used in various industries like the automotive, aerospace, and medical devices. You see, we have situations where you are maybe robots are manufacturing Volkswagen in Germany. Robots are manufacturing Benz, or Mercedes-Benz is also in Germany. And the robot is lifting the door and all of that. We have certain operations which are, far advanced in terms of certain things which have to be done in the industry way. The real-time operating systems are used for that. So let's take note of that. So normally, it has a very little user interface. Of course, you have to learn how to use it. If it's an automotive or medical industry, you have to learn how to use it. What we do, mainly in our offices and homes, is to use a Windows operating system. In the banks or in other allied organizations, there may be other usage of Linux and others for different activities as well. So the real-time operating system is looking at how it can manage the resources of a computer for a particular operation to execute in a precise amount of time every time it occurs. And basically what we should understand is where it is used. How it is used, you have to learn. If you don't know how to, there are so many things in Windows that not everybody knows how to do. That is it. For example, if you want to defragment your hard disk, defragmenting means that you want your hard disk to be sectioned properly. You want your hard disk to be divided into the right sectors. Maybe it is certain things are not right, and it's always important to do that. Windows can do that. You can clean up your hard disk. All of those things are there. Certain settings can be done in terms of the sound and all of that. So at a certain point in time, I'll show some of these things so that we understand how it works. We have single user, single task operating system. single user, single task operating system. So the name implies it's simple. You have one user performing one particular task. This means that this operating system is designed to manage the computer so that one user can effectively do one thing at a time. One thing at a time means that maybe it's a Palm OS or it's a Palm handheld computer, and you have a single user that can use a Palm handheld computer to perform one task. It means that once he's maybe playing a game, once he's chatting, that is all he can do. Unless he stops what he's doing to do something else, that operating system does not allow multitasking, doesn't allow it. And it's a single user, so one user that is doing that. That is it. We have single user multitasking operating system. So this one is a type that most people use on their desktop and laptops, computers of today. So I'm currently a single user. You are also a user. We are all single users. But whether it's your Android smartphone or a Windows desktop application or a laptop, as I'm using here, other things can be done. I can stop PowerPoint right now because Zoom is opened. That is a process that is on its own. PowerPoint is also opened. All of these are different things. Other aspects or other programs are open on my machine. That is it. So our Microsoft or Microsoft's Windows, Apple's Mac OS platforms, they are both examples of operating systems that will let a single user have several programs in operation at a time. That is it. So anytime you hear about Microsoft Windows, Apple's OS, Android for our smartphones, it allows us as users or single users to be performing different tasks or different things at the same time. The OS allows several programs to be in operation. That is it. So for example, it is entirely possible for a Windows user to be typing a note in Microsoft Word processor while downloading a file from the internet and printing the text of an email message. It is highly possible. That is it. In fact, it becomes comfortable to do that. I don't have to open my mail and then close it before I can do something else. That becomes a single user, single task operating system. And when operating systems started coming, we had those types. We had those types. It's Windows that has come to advance and allowed multitasking and all of that. You see, so it started in that particular way. Now we have multi-user, multitasking operating system. Multi-user multitasking. So a multi-user operating system allows many different users to take advantage of the computer's resources simultaneously. And this particular operating system must take into or must make sure that the requirements of the various users are balanced and each of the programs that they are using has sufficient and separate resources that a problem with one user doesn't affect the entire community of users. Once you hear multi-user, you hear multitasking, then the aspect of networking is coming in. That is it. It's networking that will bring these sort of multi-user and multitasking. So virtual, you have Unix, you have virtual memory systems, you have open VMS mainframes and all of that, different users and all of that. So it's important to differentiate between multi-user operating systems and single user operating systems that supports networking too as well. The Windows Server can each support hundreds of thousands of network computers, but the operating system themselves aren't multi-user operating systems. So you can have a situation where the server is one operating system. That particular server is one operating system. The multi-user means that you have many users that have access to that particular server that has an OS, you see, and at a certain point in time, those users access the server's operating system and then they access their own. When they access their own and do a lot of things, then it is single user multitasking. It's a different scenario. Now, when you have multitasking operating system, it means that you have so many tasks that can be done by one particular OS. And in this case, you have network users that are having access to it. So the system administrator is only one user for the Windows server or network, that one we know. And the network supports and all of the remote user logins and the networks that are available, the overall plan of the operating system and the programs are being run by the administrative user and all of that. So what actually fits with Windows is, as stated, is this one. This one actually fits with Windows, where you have a single user multitasking operating system. If you have multiple users and multiple operating systems, that normally goes into the networking environment, and that is how it works. That is it. But whichever type it is, whether it is multi-user multitasking, single user multitasking, and all of that, whether it's real-time operating system or single user, single task, and all of that, whatever the case may be, they are all operating systems that have duties of process management, duties of memory management, duties of file management, and all of that, and other duties that we'll listen to or we'll discuss later on. The next lecture should not be OS technologies. I think the next lecture is activating operating systems. So how do you activate an operating system? And then issues about the objectives of operating systems too, as well. That is what we'll discuss the next time that we'll meet. So Paul has a question. Please ask your question.
Sir, good evening.
Good evening.
Please, my first question is, you see, on my laptop, I have created a Microsoft user account for my junior brother and another account for my little sister. So whenever they want to use the machine, they log into, they don't know my password. That is the administrator's account. So are these accounts similar to the one, the multi-user accounts, as you said now?
Because it's one machine.
Yes, one machine.
It's one machine. At a certain point in time, when they are using it, you are not using it. So
yes,
although you have different accounts for them, it's a single user at the time using that particular operating system, which can multitask. So it's a single user multitasking always.
Okay.
Although you've done
my second question.
Although you've done that, at a certain point in time, it's only one user that is using that your laptop. So a single user multitasking.
At the time. Okay. Please, the second question.
Yes.
Since you were talking about the primary memory and the secondary memory,
yes,
which boosts the performance of a PC.
Yes.
I think we know that for system units, they are customizable. So my question is, are there any technology device that would help improve a laptop's performance since they are not customizable?
Oh, laptops too. A good laptop, you see, when there are factors to consider when you are even buying a computer and all of that. Laptops can also be customized. In fact, the worst case can be if you cannot upgrade your RAM of a laptop, you should be able to remove it and then upgrade it with a higher specification. If that cannot be done,
I'm relating my question to the processor, please.
Yeah, the processor is difficult. That one is quite difficult because that one, it is something that is normally stuck on the board and it's difficult to make changes to it. That is it. So normally with the processor, you see, if you have, let's say, an i5, it's not so different from an i3, not so different. The same as the i5 not being so different from an i7 in terms of speed and all of that. So, and they come in terms of what is currently being or what is currently trending and how strong your machine can be in terms of that. They go in a certain way, certain trend. But with the RAM, because of its compatibility, especially with operating systems, they always give room. The manufacturers always give room for an upgrade of the RAM all the time. And if you are able to update the RAM with a CPU that is reasonable in terms of the current trends, the machine will be okay. They don't have any problem. Okay, I think it's gone, but let me see whether there's another person. Is it Greg? Your name is not official, please. You have to, what is Greg? Greg is not an official name. You type your name in full before you join. And then you
Yes,
make sure
sir.
your index number is there. Yes,
I'll do that. Thank you very much. So please, the users that request for hardware resources, is it synonymous with the application software?
No, the application software is what will allow a user to perform a task. There should be a software that will allow the user to use the hardware. So if there's, so if the application programs or the application software, they are what allows us to do something. So for example, you want to type a report, you want to work on your CV or something. You need the application software to be able to do that. But in typing your CV, you are now going to use the hardware to be able to achieve that. Otherwise, the Microsoft Word is there, but you can't do anything.
Oh, okay. Thank you very much. And please, one more thing. With the multitasking system and multi-programming, is there any extension between them?
Multi-programming is when you have so many programs open. So you have multiple programs that are open. So for example, you are using your smartphone, and then maybe you've opened a Word application, Microsoft Word application. You've opened your WhatsApp, and all of that. All of those programs are open. Now, the multi-programming allows you to also multitask, because it means that if you've opened all of those programs, you can use program A, program B, program C, program C. So without multi-programming, multitasking cannot come in.
Thank you very much.
You're welcome. Okay, all right. So I appreciate you attending. I think I have about 141 of you online. So attendance will be recorded, and then we meet next week to also continue. Have a good night, and then take good care of yourself. All the best.